Okay, I think things are stabilized. Shall we start?
Yeah, let's start. Okay, the agenda for today. First of all, good day, everybody. Thank you for joining our webinar, Getting Started with Kubernetes. Nice to see you all being present today. My name is Titus Van Wel. I'm a recruitment consultant at Computer Futures. I'm focused on independent contractors who have experience within DevOps and cloud on the Dutch market. In collaboration with Magic Sandbox, we organized today's webinar. Jort van der Hoof, CEO of MSB, thank you for reaching out and setting up our collaboration. We are going to start with a presentation led by Mislav Stipetic, CEO of MSB. Mislav, I hope I pronounced it right, not really sure.
I've heard worse.
Thank you. After the presentation, we have a short break. After the break, we will continue with the practical side of the webinar, also led by Mislav. Some practicalities. Mute, please. Enjoy, very important. You can rename if you like, and ask questions during the practical side of the webinar. Also, just a short introduction in regards to Computer Futures. Computer Futures is an international IT staffing partner for independent contractors within the IT sector. We work with large media enterprises that are active in various areas, such as energy, high-tech, healthcare, retail, and insurance. The consultants at Computer Future also have their own field of expertise, such as Java, .NET, business intelligence, front-end, DevOps, cloud, agile, and many more. Nowadays, our role as recruitment consultants has evolved. It is more than placing the right candidates with the right roles, which we are still proficient at. It's more about knowledge sharing and building a community. Hence our principle, bringing skilled people together to build the future. We would very much like you to help us improving, so please provide us with feedback or join our community. And with no further delay, I wish you a pleasant webinar and enjoy.
Awesome, then I think we can start. Let me share my screen. I apologize for my corona hair, but yeah, I haven't been able to book a hairstylist. Let me share my screen and we can start. Just quickly about how this works, if this is your first Zoom webinar. Basically, we have a Q&A section. You can find it in the options. This is the best way to kind of ask the questions because I will be checking it often, especially in the practical part. You can definitely use the chat, but if you are using the chat, there's a toggle that says all panelists and attendees, and I think you should switch to that one. Otherwise, the messages only go to me and Titus. With that out of the way, I think we can continue. Just a quick check. Everybody can see my screen that says the Kubernetes training platform, right? Seems good. Okay. Okay, so what we'll be doing today is a kind of shortened version of our full day kind of workshop that is called Zero Downtime Deployments. In the beginning, obviously, we'll start with a lot of Kubernetes fundamentals just to explain the mental model behind it, because we found it's very hard to, unless there's this mental model present, usually what people do is basically just come with their kind of preconceived notions of how things work, and then Kubernetes looks super complicated, and they're like, why do I need to do all these things just to deploy a Docker image? But once you kind of get over this kind of initial hurdle, you'll see that there's a lot of things you're getting out of the box to do. So the first part is the theoretical part, and then after that we'll be doing the practical part. You'll all be getting a real cluster to work on, and I think it's very cool. The feedback has always been universally good. And let's get started. One more thing, there's a question about being muted. So you're all kind of in attendee mode, but feel free, there's an option to kind of raise hand if you want to speak up. That would be awesome. Instead of using the chat, we can all just chat and see how things are going. Other than that, I'm going to proceed. just a bit about Magic Sandbox or MSB.com. Our mission is to enable engineers at any company to reach their full potential. We are doing a lot of, we have a self-paced learning platform which you all get access to, but also what we do is a lot of these kind of hands-on webinars where we try to cover the first, it's a multi-day event where we try to build this kind of expert team inside of companies. So on the first day we built a real e-commerce system just to cover all the concepts in Kubernetes, storage, networking, security, things like that. And then we do more and more days of like just deep dives into specific topics. I think this slide is even old because it's missing our final workshop, which is a building CI/CD pipeline. But anyway, yeah, we're building this. It started basically out of frustration with the current state of learning. I personally have had to job hop a lot just to get kind of experience with newer technologies, and just it doesn't have to be that way. Like the principles behind MSB, our infrastructure is so cheap that we can just deploy whole clusters for people to play with, and you know they cost less than an hour of a developer's salary. And the other thing that the principle is that browsers are super powerful, and we can build these kind of guided experiences, which I hope you'll see soon. What makes it a bit different is we are all about Kubernetes and the kind of adjacent technologies around it. And so it's not like we have like 50 technologies, which is a big selling point for other platforms, but we do one, but we do it very, very well. And yeah, partner with us is Nigel Poulton, author of the Kubernetes book, great guy. And he's developing content on the self-paced platform. This is the learning platform, but this is the kind of problem that we're trying to solve. This is the current state of, I think, learning. Step 1 is a stateless hello world app. Step 2, build the rest of the damn cluster. And we hope to fill in this gap. Yeah, this is our agenda. So we'll be talking about the Kubernetes architecture. We'll be talking about a few specific Kubernetes objects, trying to tie it all together, and then using the knowledge that we had in the theoretical part, we're going to be actually building something on Kubernetes in the practical part. The start of this, okay, we're now getting to the actual kind of intro to Kubernetes now that we've gotten this through. It's going to sound a bit weird when I'll be talking now a bit through these concepts, because I'll be using these abstract terms like, I don't know, piece of software or work unit or something like that. The reason is simply because I don't want to throw all this kind of Kubernetes jargon. And it's going to sound a bit awkward, but we'll get there. I think Zoom insisted on me making an upgrade. I hope not a paid upgrade. I hope it's sorry. What was I saying? Yeah, the big problem with Kubernetes is once you start learning, it's just all this new jargon of like deployment manages rolling updates of replica sets and pods and weird things like that, which technically makes sense, but you know it's very hard to kind of grok what exactly they mean by that. So I hope this kind of solves it. So how we like to explain Kubernetes is to start basically from the other side. Instead of us talking about Kubernetes, we'll be trying to solve a problem and build it from the ground up. So we'll be tackling a very simple problem of you need to deploy some software on some machines. And we'll be seeing how to evolve the system to make it better. And spoiler alert, no, it's in Kubernetes. But let's get on with it. So yeah, as I said, imagine we have a situation right now. We're engineers and we have to deploy 3 containers running on 3 nodes, so on 3 machines. So we're going to call them now node 1, node 2, node 3. We have Docker running on each machine, and basically we have 3 things that we have to deploy. So the simplest way to do it would be use your Docker CLI, connect to the daemons on each machine, and instruct, hey, run this thing. Okay, we have 3 containers running. Technically, we solved our problem, but you know, it's not a good solution. So it's a manual process. There's no healing. Like if a container goes down, it's going to stay down. IPs are hard-coded. If a node goes down, it's bad. I think we can all agree that it's a bad situation. But let's kind of evolve this kind of process a bit. So what we've added now is this process called, let's call it an exec. And what this process does is, let's say, reads from a text file for now. And this text file tells it, okay, this is what you should be running. So node 1, run Nginx, node 2, run Redis, node 3, run Postgres. So, okay, suddenly it's still not an ideal scenario, but at least they kind of have some kind of state and know what they should be doing. So it's a kind of, we solved the problem, but still not good. If a node goes down, still everything's hard coded. It's not a good solution. Let's improve it a bit more. So let's change up a few things here. So first of all, instead of our static text file, we will put some kind of, let's just say we're going to keep it as a configuration right now. And what we'll be doing is putting in a REST server in front of this configuration. So instead of the execs reading directly from some kind of file or something, they will now be communicating through a REST server because everything is better with the REST server. So the two major things that we've changed here is, first, if you can have a look at the configuration, it's not static anymore. We're not defining the nodes on which we want to run things. We are just saying, hey, I want these 3 things running. So yeah, I see now here it says Docker latest. It should say something which makes more sense, like Redis, but it doesn't matter. So we're just defining our desired state. We're saying we want these 3 things running. So what the exec processes need is a combination of a work unit to be run, which is a kind of definition of a container. And they need to be, this work unit needs to be assigned to a node. And once that happens, the exec process has full information of what it should be running. And now the second key part that we're adding is this, let's call it control loop for now. So what the control loop does is constantly monitor the current state, which in this case is blank. Yeah, so I forgot to mention that the exec processes report back the current state to the central server. So what the control loop is constantly doing is just comparing the desired state in a current state, basically a for loop that's kind of repeating indefinitely. And if there is some kind of difference between these 2 states, it's going to try to fix this situation. So right now we have the desired state, these strings have to be running, the current state is empty, the control loop obviously notices it and says, okay, this you run on node 1, you run on node 2, you run on node 3. As soon as this is published, as soon as this is kind of set, this is what should be done, the exec processes have all the information to run what they should be running. So it's a bit more kind of organic system. We're going to change just one more thing, which is simply because we're kind of good engineers and we're doing a bit of separation of concern. The control loop will only publish, we're going to take the previous step, which is publishing of the work unit and assigning it to a node. We're going to separate it in 2 different processes. So one is the control loop, if it's going to be matching the desired state and the current state and trying to fix this. And the assigner, we're going to call it for now, is going to be seeing if there's any work orders that should be running but are not assigned to a node, and it will assign to a node. Okay. I see some chat that some of you are having technical issues. I don't think it was mentioned, but yeah, we are recording this session, so we're happy to send you if you need some. So let's just go back. Okay, what's happening right now? The desired state and the current state are obviously in a mismatch. The control loop says, hey, I need these strings to be run. At that moment, the assigner sees there are 3 work units that are not assigned, checks the available nodes, assigns it to node 1, 2, 3, and okay, we have a complete set of information for the execs and the system is running. So let's go through a few kind of failure scenarios to see how the system responds right now. So let's say this pod goes down, something happened, I don't know what, but it's going down. As soon as this happens, the exec node, the exec process notifies, hey, this is the current state right now, I'm not running anything. The control loop notices it, says, hey, this needs to be ran. The assigner says, hey, it's unassigned, assign it to an available node, and the system has healed. let's see what happens if a whole node goes down, a hardware failure. Again, we see that the current state and the desired state is not matching. The control loop obviously notices it, does its thing, announces this needs to be ran. The assigner sees, hey, there's something unassigned, but only 2 nodes are available, assigns it to node 2, and here we have a healed system. So a few things that I would like you to notice in this kind of scenario is, one, that each of these things is doing only one thing, but doing it well. So the control loop has a specific task, the assigner has a specific task, configuration management has a specific task, and they are all kind of working together. They are all working individually, but the second key point is that at no point did the control loop ping the assigner and say, hey, there's something new that you should be doing, or the assigner check with the execs how things are going. Everything is just looking at the REST server and looking at the central state and trying to make changes, trying to respond to changes on the central state. And by doing that, they are achieving a kind of higher order function by doing one thing well. So as I said, now that we've kind of built this kind of system, as I said, spoiler alert, this is basically Kubernetes. We've gone through basically all the main processes in Kubernetes, and this is what, if you were to manually deploy Kubernetes, you would be deploying these exact kind of things. So right now we're going to stop using these kind of abstract things like control loop and assigner. We can talk about specific Kubernetes processes. So all these things, so what Kubernetes is basically a combination of one or more master nodes and one or more worker nodes. So the master nodes provide these kind of central processes that are vital to functioning of Kubernetes, and most importantly, state management. And the worker nodes are basically listening to orders, and they are providing these pools of resources for your containers to run on. So the process that we've been talking in abstract terms are, as I said, actual control Kubernetes processes. The master node consists of the Kube API server, which on the one hand is just a kind of dumb REST server, but obviously that is vital to everything inside of Kubernetes and does a few more kind of smart things like authentication, validation of inputs, things like that. But it is all the communication in Kubernetes goes through the API server. You'll be seeing later once we interact with Kubernetes by using the binary that you have on your machines. What this binary does is basically reads the configuration, where is the API server, and just does a series of REST requests based on what you tell it to do. The configuration part inside of Kubernetes is literally kind of very similar in principle to what we've been talking in abstract terms, but in Kubernetes terms, it's always, by now, yeah, still it's always an etcd cluster, one or more clusters. So this is where the actual configuration is stored with Kubernetes, and the API server does manipulations on it. So, sorry, just a second, please. Okay, so as I said, the API server provides validation. On the one hand, it's a dumb REST server. On the other hand, it is vital to everything that's happening in Kubernetes. The Kube scheduler, yeah, this is also a very important part. The Kube scheduler its basic task is to see a work unit that has to be assigned to a cluster. If it's not to a node, if it's not assigned to a node, it does a process called node binding and just instructs this is where you will be. It's been taken out. Basically, it's meant to be kind of pluggable. You can build your own scheduler. It's really not that difficult. If you want to build your own, you're just listening to these, let's say, work units for now. If they're not, they don't have a node assigned, assign them to a node. But I would suggest, unless you really know what you're doing, to keep with the default Kubernetes scheduler. And the reason why is because it's actually very powerful. What you can do with it is through a set of, let's say, kind of labels for now, or annotations. You are able to say things like, imagine you are deploying several Postgres instances on your cluster, and you do not want them to be all on the same machine. So, because if this machine goes down, you will lose several instances of your database, which is not a good scenario. So you can tell this type of pod never kind of put on the same machine. Or you can say these two things will, I'm sorry for using the word pod, let's say work unit, or these two containers will be communicating often together, and so try to put them on the same machine so they can reduce latency. There are a few more cool things that you can do with it. Some classic example is, hey, I'm running, I don't know, TensorFlow, and my machine needs GPU installed and access to it. So it's a very kind of powerful, simple mechanism, but you can build this kind of hierarchical topologies of how you want stuff to be distributed in a cluster. But yeah, it's basic. What it does is finds a work unit that's not been assigned to a node, checks the available nodes, and assigns it there. And then comes the kind of magic part, which is the kube controller manager. So the definition says embeds the core control loops shipped with Kubernetes. When we say control loops, we mean literally as a kind of how robotics thinks of control loops, which is basically just a process, let's say, that constantly monitors the current state and the desired state and tries to kind of fix the mismatch there. It's literally a binary that has all the code for different controllers that are shipped with Kubernetes. And what controllers are basically things that monitor the state of your cluster and respond to changes based on their purpose. So you have several different controllers. If you work with Kubernetes at all, you probably use something called a deployment, which is, let's just say, a very simple controller that maintains a certain number of, let's say, Nginx instances running. So you create a deployment object and say, I would like there to be 5 Nginxes running at every moment, and then this controller will try to maintain the state. If 2 go down, 2 immediately 2 will be restarted. This is a very basic kind of controller. It's very useful, but there are different kinds of controllers that you can think of, different kind of patterns of defining how you want your containers to be deployed and respond to changes. But this is where the magic of Kubernetes is, and the controllers shipped with Kubernetes are very useful, but you can also build your own. In essence, what they are is something that's listening to changes in the central state and responding to it. But it will become clearer much soon. I'm just checking if there are any questions. And kind of, I don't know, maybe I'm talking too fast. I'm sorry, I get into it somehow because this is not my first thing. Is everything clear so far? And like, some positive feedback or negative feedback, anything is good, just so I know you're participating. Okay, nobody's picking up. Now I'm getting worried. I guess you would tell me if things are not working. Okay. All good. Okay. Let's talk about the worker nodes. Thank you, Hugo. So the worker nodes are, as I said, they provide a pool of resources that is used to deploy your actual containers. So they also have basically 3 processes running on them. One is a kubelet. We've been talking about it so far as this kind of exec process. What it does is receive a list of, let's say, work units or containers. I can't use the proper words yet, to be run, and this is what it does. And if something goes wrong, reports it back. It's the only thing it does. The second process is kube proxy. We won't be going too much into it today, but basically what it does is maintains the networking of Kubernetes. So Kubernetes provides you these basic primitives of networking, and this process is what's actually running on each machine that deals with IP tables or DNS to ensure that things are set up properly. But you very rarely interact with it directly. And the third thing that's important to be running is CRI runtime. So it's a container runtime implementation. Basically, there's an open standard of how a container runtime should be, which interface it should adhere to. So you can use Docker, you can use containerd, you can use Kata containers, you can use whatever you want. But basically, this is what's actually Kubernetes using to run your containers. Standard is Docker. We on the backend use containerd, but it's all just a trade-off, and you don't really care that much when you're using Kubernetes. Yeah, as I said, the kubelet listens to a list of work units that it should be running, reporting things back. Kubeproxy is dealing with the networking, shifting packets around, dealing with DNS. One interesting thing with the CRI runtime is there is actually a project called, I think, a Vertlet, that is a CRI runtime implementation of hypervisors using virtual machines. So, which means that you can actually use virtual machines as containers, and it's a pretty interesting thing because it works extremely well. We used it for a while, but what it allows you is a kind of, if you're shifting from, let's say, virtual machine world onto Kubernetes, it allows you, let's say you have this big thing that's hard to split up into smaller services. You can actually run it, and it's expected to be run in a virtual machine. You can actually run it inside of Kubernetes on a virtual machine, and then slowly kind of take it apart. But it's a bit more advanced thing. Just a quick note of kind of how Kubernetes is flexible. Oh, Manish says my voice is going up and down. Oh, sorry. Put my microphone here. Is this better? Is it too loud maybe now? Okay, I'll be checking to see if this is better. Okay, sorry about that. Okay. So, now that we've been talking about this kind of abstract terms of work units and things like that, we can now talk about actual Kubernetes objects. So, first thing to note is that everything in Kubernetes is represented as an object. Everything basically that you will be using and interfacing with. So, persistent volumes are an object. Policies are an object. The actual nodes you run them yourself are represented as objects. So you will be, every time you interface with Kubernetes, you're either writing or editing or deleting an object, and then Kubernetes does things in the background. What's important to note is usually when you deal with these objects, they are represented as manifest files, and you can either choose to use YAML or JSON, and obviously I think YAML is much more human readable. But what's important to note is that they all have the same kind of structure. So this is a bit, let's say, more complicated example, but we'll just go through it quickly, just to kind of show you that things make sense and like it's not that daunting, and to show off a bit of a structure of how a Kubernetes object works. So here, please don't mind the actual kind of meaning behind this. What does everything mean? Let's just talk about the kind of structure of an object. So every Kubernetes object has 4 fields: API version, kind, metadata, and spec. So the API version, kind, and metadata basically always have the same schema. So the API version refers to, let's talk about the kind first. So the kind is the actual type of an object that you are defining. So in this case, I mentioned before this deployment object. So in this case, we are defining something that, if you remember, should maintain a certain set of replicas running. So this can be kind, I don't know, pod, kind, persistent volume, kind, node, whatever it is. But this is basically what defines what this object is. The API version is basically just the versioning of the implementation of this type of an object. So here we can see that this is in apps v1 namespace. There are different namespaces for different purposes, and the reason behind it is, as new objects are introduced, you don't want your cluster to go down if your Kubernetes, you upgrade your Kubernetes cluster. The idea is basically the deployment is fairly newish, let's say, but before maybe a year or two ago, it was in apps v1, beta 1, apps v1, alpha 1. So it was kind of progressing through the different namespaces. And just the idea is that, you don't break an interface to something that you're expecting to be running. It's not that important. It will become clear much more soon. Usually just look it up if you don't know in which namespace an object is. Let's talk about the metadata a bit. So API version kind, we went through. The metadata has one mandatory field, and it's the name. So if you think of an API version as a kind of grouping of an object, the kind then kind of narrows it down to a specific type of an object, and then the name gives it an actual identity on the cluster. So every object that's running on a cluster, every entity has to have a unique name. So in this case, this is an MSB web deployment, and the name is mandatory for all objects. The second part is what's usually there are the labels. So it could be a bit confusing because it says class deployments, but by themselves, they do not have any kind of semantic meaning, but we'll see later that they are a very kind of powerful mechanism to kind of connect or reference things inside of Kubernetes. So these things can be something like tier front-end, purpose, database, I don't know, something like that. And you can have obviously multiple of them. And now the spec field. We're just gonna go quickly through it. But so the schema of these objects of API version kind and metadata is always the same, but the spec field is unique to each kind of an object, which kind of makes sense. Each kind of an object has a different purpose, and these are the kind of tuning knobs of this type of an object. So let's just go quickly through it, and I think if you just read through it, you can see we can see replicas too, which looks kind of self-explanatory, which means maintain 2 replicas. And if we again go through stuff, we can see, okay, there's a spec, a list of containers, Nigel Poulton, MSB, hello, 101, port 8080. So if we just go through this, we can see that it kind of, I think we can recognize that this should maintain 2 replicas of containers of Nigel Poulton, MSB, hello. So this is a bit medium kind of complicated example, and we'll be writing deployments fairly soon, but I would just like you to remember API version kind metadata spec is unique. All of these are always with the same schema. Kind defines the object, name is mandatory. And we'll build up on this knowledge in a bit. Okay. Give me a sec, please. I'm happy we got to this point because I can stop using abstract terms like work units. Every time I talked about containers or something like that, these work units, I was actually talking about pods. So a pod is the basic unit of execution inside Kubernetes. So even though we say Kubernetes is a container orchestration platform, we're not ever dealing with containers directly, but we are dealing with this kind of thin wrapper around these containers called pod. On the one hand, they are very kind of dumb. Let's say they provide a kind of isolated environment for your containers to run in. But on the other hand, they're key to everything, and everything basically revolves around pods or attaches or routes traffic to it. So this is what, like if you're running a Redis instance, you're running it inside of a pod. There are several types of pods, 2 types. One is a multi-container pod and a single container pod, which means either running 1 container or more containers. Let me show you. Yeah. So if you're running like you just want to run Redis or your invoicing service or your payment service or something like that, you would build a container and then write a Kubernetes manifest of a pod and say, hey, you run this container, and that's it. The other use case is multiple containers. Basically, the idea is that sometimes things need to be working together, but they don't necessarily fit in the same container. So if you put a multi-container pod, they will always be run together as a single unit. The idea behind the pod is simply because once you run something as a multi-container pod with this kind of layer of abstraction, it means it's meant to be working together, and they can communicate very easily. They can share volume, they share the whole network stack, they can communicate through localhost. Let me just actually show you an example. Yeah. In this example, we see an example of a multi-container pod. Imagine you have a web server, kind of just a default Nginx that is serving whatever is in its shared folder. And imagine in the second container, we have something called a file puller. So this could be like a simple, maybe cron job or something that repeatedly checks for a source of content that's updating, fairly regularly. So what we can do is then take this content manager that's constantly pulling things and take the web server that's serving stuff off of its volume, off of its file system, and have them very easily communicate through a shared volume. And basically whatever the content manager puts into his own kind of file system is immediately visible in the web server. The key part is to know that while these two, if we run several of these replicas of this kind of configuration, these two can very easily communicate together. These two can very easily communicate together. They will always be deployed on the same machine, sharing everything together. But to get them to communicate between each other, it requires a bit more work. So they are like a basic execution of Kubernetes. What's very important to note in this point right now is, imagine you're running a web server. So you would like 5 instances of your web server running for kind of scalability purposes. You would not be running a pod with 5 containers of this web server. You would be running 5 pods with a single container. So you scale up and down using pods. Okay, I hope this is clear. Just a sec, please. Okay. Let's have a look at now a specific Kubernetes object that we kind of understand its purpose. So API version kind metadata spec, it's always there. And this type, now we're defining its kind as a pod, which is this basic unit of Kubernetes that allows you to run a container. It's in the API version v1. We're going to give it a name Nginx. We're going to give it a label, which is not very useful, but okay, it doesn't matter. We can put whatever we want. And then if you have a look at this, I don't know if you're not familiar with a YAML, when you see this, that means it's a list. So here we literally see a list called containers. It has one item. We're going to name it Nginx, image Nginx. This is the actual, like if you run Docker pull Nginx, you pull it from the Docker hub, and we're going to open the container AT. So this is the basicest kind of, a very basic YAML file, one of the simplest YAML files that you can run. But if you take this and post it to an API server, Kubernetes API server, it would actually run a pod with an Nginx running and open port 80. Okay, cool. Let's give an example of a multi-container pod. Like, it looks a bit more scary, but I think to see it makes sense. So again, API version kind metadata spec, but this time we see 2 items in the list of containers. So one is Nginx container, the second one is a Debian container. And now on the pod level, let's just talk very kind of high level around this. We see one volume defined called shared data. And what's different from the example before is, just say, yeah, the Nginx container will serve whatever is in user share Nginx HTML, while the second container, we're just saying, hey, just run this command. So inside of a shell, run hello from the Debian container and write it into pod data index HTML. And then the key part, what we're doing differently from the last point is we're using this volume mount, which I hope sounds a bit self-descriptive, but we are mounting this volume inside of both of them in different mount paths. So maybe just a quick question to see if anybody can figure out, if we, once this is like running, if we make a request to the Nginx container, what would the Nginx container return? Somebody. Radhika, yeah, but what's inside of the index HTML? Yeah, hello from the Debian container, exactly. Okay, I hope this kind of makes sense, but you can see how easy it is to get them to communicate. We're just defining on the pod level, just think about the structure a bit, mounting it inside each container on the different points, and we can just communicate. So yeah, as I said, we will rarely create individual pods. They work best under the management of one of these things we talked about called a controller. A nice way to say it, pods are ephemeral. The kind of standard way to say it, which is a bit not nice, pods are cattle, which means while they are critical to Kubernetes, while they run everything inside of your kind of software, do not rely that they will stay there. They can be, you know, shut down. They can be moved to another machine. They, like, just treat them as building blocks, but do not rely on their kind of identity or anything that they give to you. If they go down, they stay down, unless there's a controller that notices it and says, hey, run a new one. So yeah, pods are cattle, basically. Okay, let's talk about the second abstraction, which is a service abstraction. So the idea behind the service abstraction is, while the pod is a basic workload abstraction of Kubernetes, a service is a basic networking abstraction of Kubernetes. You'll see it's fairly simple. Now, it maybe looks a bit complicated on the slide, but basically the idea behind it is, I think, yeah, it's here. As I said, pods are cattle, and basically, while they do have their own IP, and you can literally send a request to a pod, you do not want to kind of keep track of where each pod is. What you do is define a service, and then there is a very kind of simple but very powerful mechanism to define the pods that it should be routing the traffic to. So from that moment on, you're just sending traffic to this service, and it's doing all the magic for you in the background. The idea is, you know, you have, I don't know, 3 web servers, and Black Friday comes along, and you have to increase it to 50 or 500. It doesn't matter how many. The idea is you don't want to manually keep track of where all the pods are to send traffic to them. All you're doing is sending traffic to the service abstraction, and then it's in the background load balancing to all the pods behind it. So the idea behind a service is it's a very static, like a hard network endpoint inside of your cluster that you can rely is going to stay there, and you can reference it as long as it's alive. The pods behind it can die and move, but for as far as networking is concerned, you only care about the service. It's a bit confusing. It's we say capital S service, so in Kubernetes terms, because what's confusing is, you know, you're used to thinking my invoicing service, my payment service, my whatever, as the actual process that's kind of doing the things. But in Kubernetes terms, it's a networking abstraction that's actually routing traffic to the processes that are actually responding, right? So I think I can, let me show this first. So here again, I hope this is becoming a bit familiar. API version kind metadata spec, kind service, metadata, we're gonna call it my Nginx, and we are defining a port. Let's say we want the port 80 to be open, and then the selector is the key part. I think it will become obvious here. So the idea, as I said, if you remember, we have a pod here and a service. And I remember when I said that the labels don't matter semantically much, but they are very useful inside of Kubernetes. And this is what I meant by. So this should be indented, actually, sorry. So we gave this pod a label of run my Nginx. And then we define a service and say, the selector is run my Nginx. And what this means is, keep track of all the pods that have this label, run my nginx, and route traffic to them when traffic comes in. So this is the kind of binding, the label and the selector are the kind of binding glue that the service knows where to route traffic to. So once you have a label on a pod, it doesn't matter whether there are like 1 or 50 or 1,000 pods, you don't care, the service will route traffic to this kind of set of pods that are correctly labeled. Does this make sense? I think it will, like we will be actually like deploying services. You'll see what I mean by that. Just quickly, the types of services are cluster IP. So it's the default version, which means as soon as you create a service, there will be an IP created inside of the cluster. The question is the assignment round robin. Not strictly round robin. It tries to do it, but it's semi-random. Like you can attach it to it, attach stuff to it, sorry, to make it kind of smarter. And then there's like service meshes, things like that. It's kind of round robin-ish, but also fairly random of how it routes traffic to them. So the cluster IP, as soon as you create it, cluster internal IP will be created, and everything you send to this IP and port will be routed to the ports that there should be. The second part is, the second level is a node port service. So it's not really like tied to your business logic. It's a very kind of DevOpsy construct. So what it will do is expose a port on each machine, something like 35,000 plus. So all the traffic going to this port, but on any machine in the cluster, will be routed to specific pods. And then the third is the cool one, which I really like as an example that shows you how Kubernetes deals with a lot of the kind of messiness of the real world. Is on a properly configured cluster, whether it's on AWS, GKE, your local cluster, if your team did a good job, when you define a load balancer type service, it means interface with my cloud provider or whatever is there, provider of publicly available IP addresses, and hook up my service to it. So we have support on MSB for it, and you'll see like you literally just say load balancer service, and you get a publicly available IP that we can address from anywhere. And the reason I like this example is just to show you how, unless you're doing something super fancy, like if you write your application for Kubernetes, you should be able to run it very easily on any cloud provider as long as it's properly configured. So this is the kind of messiness that's being hidden from you. Another, let's say, example could be persistent volumes and that kind of dynamic provisioning of persistent volumes. Like there's a persistent volume object, there's a storage class, and you don't care what's behind it. You just say, I want my data persisted on this volume. And the final part is the external name. It's just basically an alias to an externally available address. Okay. One more object that I would like you to introduce to you is deployment. It's one of these controllers that are used to manage pods. It's like a definition is deployment provides declarative updates for pods and replica sets. So it's an example of how, if you're new to it, can be a bit confusing, but let's just conceptually talk about it. What it does is maintain a certain set of replicas of something running. So you say, I want 5 nginxes running. If 3 go down, it will immediately schedule 3 new ones. So this is one of the controllers in that control loop process that we've been talking about. There's like very fancy things you can do with it, but its main kind of purpose is to maintain a set of replicas of a pod running. I think we can now go through a bit this object, and like in the beginning it may have looked a bit complicated, but now I hope it's a bit more clear. So API version kind metadata spec, as always, kind deployment, name is mandatory, we call it nginx deployment. The label we can put it, but in this case it doesn't do much. But here, let's have a look at the spec now, the spec of this deployment. So replicas field 3 is I think fairly self-explanatory. We want 3 replicas running, but I would like you to have a look at this template field and tell if somebody can recognize what does this kind of remind you of. Yeah, very good. It's actually, yeah, it's a pod definition. It's only missing API version and kind, because it's assumed that it's a pod. But yeah, so what you can think of this kind of deployment is object is that it's a factory like that will produce pods based on this template and maintain 3 replicas. Another just kind of thing is it has a selector, so you say match labels app and Nginx, and so they have to match. This is simply so the controller knows which pods are under its kind of control. But yeah, what this will do is maintain 3 replicas of a pod with running Nginx on it. It's simple, no? Okay. What we'll be doing now is this. I'll be talking a lot right now. This is basically the final part where we tie it all together. It's very important if you're not following along to kind of interact me and ask me. I forgot to say, like, if you have a question, please ask, because if something's not clear to you, probably there's other people there. It's my fault I didn't explain it well. So, like, please be as interactive as you want. Just, it's important that you understand these things before the practical part. Okay. So we'll be going through a kind of similar situation as before, but with a bit more detail. So we will want, so the situation that we are now, kind of the snapshotting of the current state is, we have just created a deployment object that is that wants to maintain three replicas of, let's say, Nginx. It doesn't matter. So let me just show this for like UX purposes. When you see these kinds of things, so okay, the black things here are different. We can call them controllers. So this is a deployments controller. It just received, hey, you should maintain 3 replicas of Nginx running. This is the scheduler. This is the process that's assigning unassigned pods to available nodes. So if you remember the scheduler that was on the left. I'm just going to shortly introduce this concept of an endpoints controller. It's not super critical, but I think it's important that you know how things work. So if you remember when I said, if you declare a service and a selector is going to target whatever number of pods are behind, and what's in the process that's actually in charge of maintaining this list of healthy running pods with correct labels is something called an endpoints controller. So the endpoints controller gets basically activated automatically as soon as you create a service object. So it's running in the background, but it's important to know that it's the process that's actually maintaining this list of healthy running pods with correct labels. So as long as stuff is in his list, the service will route traffic to them. And the kind of UX thing that I need to explain to you, if you see text here, that's not the internal state of these kind of controllers. It is just, let's say, their view into the central state is the things that are important to them. So, okay. So let's go into a situation where 3 Nginxes had to be deployed, and what we've done is created a service that will route traffic to them based on their labels. So they will be created 3 pods with the label app Nginx, and service is configured to route traffic to them. So let's see the kind of process step by step how it goes. So deployment controller sees, hey, okay, I'm scheduling these 3 pods to be run. They're in a scheduled state, so it's still kind of waiting. As soon as this happens, the kube scheduler notices, hey, there's 3 pods that are created but not assigned to nodes. As soon as that happens, it assigns it to an available node. Now the kubelet processes have the complete set of information what they should be running, and here we have 3 Nginxes running each on their own node. So this was a snapshot of the exact moment that they went into a running state. So as soon as the kubelets reported to the central state, 2 things happen. And I'm doing it in parallel intentionally just to show you that these are parallel processes. One is that the deployments controller recognizes, hey, my 3 pods are in a running state, I'm happy. And in parallel, what happened is the endpoints controller also noticed this. So he said, hey, there's 3 running healthy pods that have correct labels. I'm putting them in my list, and traffic is being routed to them. So you can see now how they're all just doing their one thing, but just using this kind of, let's say, labels to kind of bind them all together, suddenly we have a running system with traffic being routed to them. Let's see what happens if a node, this pod goes down. So either something goes bad or a cosmic ray hits the memory bank and changes it. We don't care, it's going down. So as it's in a terminating state. As soon as it's in a terminating state, again, 2 things happen. One is it gets removed from the endpoints controller's list because even though the label is correct, it's not running anymore. And the deployments controller notices, hey, okay, it's terminating, something is not good. So how the deployments controller will react? So again, 2 things will happen. The traffic is no longer routed to this dying pod. The deployments controller immediately reacts, hey, there's 2 running, there should be 3 running. He schedules a new one. The kube scheduler sees it, hey, it's unassigned but scheduled, assigns it to a node, the kubelet sees it, okay, I'm running it, it's going into a running state. Immediately it appears in the endpoints controller list, and the deployments controller sees it's running, it's happy, and the traffic gets reestablished. Okay, this has been a lot of talking, but what's important what I'm constantly stressing is that they're all just kind of parallel processes that are doing one thing and doing one thing well. And through their just kind of this basic kind of interaction, we just have a self-healing system that's routing traffic dynamically to whatever is alive. Now I need some feedback. Is this clear? Have you been following along? Is this good? Because it's very important that we go through this part. Radik raised hand. Awesome. How do I do that? Sorry. Participants. Okay, I don't see a raised hand anymore. So questions are, is there any time between auto healing of pod? Yeah, yes, there is a very small amount of delay, obviously, until it gets reported and things are, it's usually very quick. You'll see now in the hands-on part how quick it is. When you should be worried about that is when you're running these massive deployments, like CERN runs Kubernetes on 15,000 nodes. So from all intents and purposes, it's very quick, but also we will be actually doing this today. There are certain mechanisms to kind of smooth it out and add some kind of sanity checks to this process. Will all the controllers be running on the control node? I think you mean master node, and yes, the answer is all the controllers shipped with Kubernetes, yes. If you build your own controllers, they're actually running inside of the cluster. What happens if the master node itself goes down? Yeah, it's not a good situation. Things will keep running, but all the communication, everything goes down. All the self-healing goes down because obviously there's nothing to report on. So your kind of system will be just in a frozen state, but it's functioning, but if anything goes bad, it's gonna just stay there. So you should avoid the master node going down, definitely. And kind of what Kubernetes is evolving in, once you rent a managed Kubernetes cluster, you basically get the master maintained by GKE or whatever you're using. It's very interesting that the Kubernetes is actually just evolving into basically an API. We like to say that Kubernetes provides you with a set of patterns. So you just post it to the API and you don't care what's happening in the background. So what you can actually do is connect AWS Fargate to a Kubernetes master. And this just gives you infinite nodes. And then you just don't care how things are deployed. You just post to an API and happens. Okay, if things are clear here, then the one more thing I want to show you is the kubectl or the kubectl command. This is the standard format of it. This is what you'll be using to interact with your cluster. So if you say kubectl get pods, which means get all pods. If you say kubectl get pod nginx service frontend, means give me the info of these exact kind of objects. So you can, this can be delete, this can be edit, this can be a lot of things, basically CRUD operations. The important thing is if you just specify the kind, it means all the objects, but if you say kind/name, this means a specific object. And the final thing is kubectl apply. This is what we'll be using a lot. It just means read whatever is in this YAML file that's locally available and post it to the API server and make stuff happen. So if there's a pod defined in there, we'll be creating a pod. If there's something else defined in there, we'll be creating something else. So yeah, this is apply my manifest file. So if things are clear right now, we'll be taking a small break and then we will get to the hands-on part. Is this okay? Should we take like a 10-minute break?
Yeah, let's take a 10-minute break.
Awesome.
Awesome.
I'll be in the chat, and if there's any questions, just let me know.
Can you hear me, Ario? Somebody hear me? Okay. Great, great. Mislav, I think you have a question. So for the people that are still listening, is everybody ready for the practical session? Great.
Hey guys, sorry, I just took a bit of a break. I had to scale up some clusters and stuff. The question was, I want to understand about probes in Kubernetes. I'm new to this technology. Okay, so to prepare, all you need is Chrome, Google Chrome, preferably, and if possible, a big screen. But other than that, it's all good. The question was about probes, and this is, I guess, if you mean the Kubernetes liveness and readiness probes and things like that, this is actually very good because this is exactly what we'll be doing today. So I'm gonna wait. I think we have 2 more minutes and then we will proceed. But just in general, are you finding it useful? Every time we do this workshop in the Netherlands, like the feedback is very minimal, but I'm used to it by now. My co-founder is Dutch. Okay, thank you. Bastian, you'll see. I think there's something special about MSB. I don't know if any of you have tried MSB before. Yeah, security is a one-day course. So yeah, we have, it's all in, our full boot camp is kind of 6 days, but we usually, not everybody needs to know everything. So we usually do a big kind of batch of this kickoff, so everybody knows the basics. And then we have, okay, this team will be dealing with storage. Let's deal with storage with them. This team will be dealing with deployments a lot. So yeah, it's very kind of custom. Has any of you used MSB before? It's actually like you can just go and use it. Okay, I'm going to switch now. I think I've scaled up your clusters. It's good. So if you could go to workshop.msb.com, I'm going to wait, I think, yeah, 10 minutes has passed. Am I sharing my screen? Yeah. So if everybody can go to workshop.msb.com, I assume everybody's back. I know this question doesn't make sense. I can't ask who's not here, but I hope you're back, right? So we'll be going to workshop.msb.com. And you'll be greeted by this. So if you can log in with Google, that's the simplest way. We have a Google login. If not, there's a sign up here link, okay? And you have to click sign up here and like just create a basic username password. We won't sell your data. It's just important to have some kind of reference for a user to assign a cluster with. So sign up with Google is the simplest one. Otherwise, you have sign up here. So can everybody go through this process? Usually we don't have any issues, but if we do, it's obviously very important that you let me know and we resolve it. Once you log in there, you will be greeted by something like this. So this is, yeah, we only have a few kind of workshops here now unlocked. I'm going to give it like a minute. If nobody's complaining, I'm assuming things are going well. So if somebody's having trouble getting to this point, now is the time to speak up. Okay, so what we will be doing, and it's very important now to pay attention because usually there's always somebody that somehow ignores this. We'll be clicking the zero downtime deployments topic. So it's important to click the zero downtime deployments, and then there's only one class unlocked now. It's called zero downtime deployments intro. So for you, this is going to be green. For me, it says restart because obviously I went through it a few times, but you should see a green start button. And okay, let's click it. So again, if nobody's complaining, I'm not complaining, like letting me know that things are not going well. I'm assuming everything is going well. Okay. What we have now is, okay, thumbs up, thank you. What just happened now is, this is the MSB learning environment. You just got assigned to a real cluster. I'll show you exactly how it works very soon. Let me just kind of quickly go through the kind of UX of the MSB kind of platform. So first of all, if you're working on a bigger screen, you can extend this left part like using these arrows. So I'm going to extend it a bit. The second important part is this green button. Sometimes it says continue, sometimes it says start tasks, but this is how you progress through the class. So I'm going to be clicking Start Task just to go into work mode. So here is a kind of full ID environment that we have now attached to this cluster. If you're working on a smaller screen, what you can do actually is if you click this, so the left of these two, it's very important not to click the right one. The left one, if you click it, you get a kind of full ID environment deployed that's connected to this cluster. So if you're on a small screen, sometimes it's, or when we're doing like very complicated workshops, then we are using this environment. But yeah, it's the same way you're working with. And then the kind of cool part of MSB is this right part. And you'll see very soon what I mean by that. This is a live visualization of your cluster. And the idea behind it is, you'll see once we do a few actions, if I try to explain it, what's happening, it's very, it takes time. But if you see exactly how things are evolving, then it makes much more sense. And I think this is what makes MSB cool. And this is what I said when I said we're built for Kubernetes. Okay, up here, we have a practice kind of task. Here you will see what you should do to kind of follow along with the lesson, and let's go to work. Right now, we just says run in our kind of terminal, kubectl apply f pod. I'm not going to run it just yet. So let's just have a look quickly in the actual YAML file that we're going to be applying. So if you remember, I said apply means post it to the API server, like make this happen, whatever is in this YAML file. What we'll be doing is, zoom in a bit, deploying this YAML file, which is the basicest, as basic as it goes. So it's a pod that has a name of my app, and it has a single container that's running BusyBox, which is a simple kind of Linux distribution, let's call it. We're just going to be running a command, hey, hello from Kubernetes, and then sleeping for a bit. While you're in this kind of environment, what's cool, one of the cool things about MSB is that you can hover over these fields, and then you get an explanation of exactly what's the purpose of this key. But for now, let's just stop talking and let's run kubectl apply fpod.yaml. Okay, and here on the right, now we see the visualization part that I've been talking about. So here is our pod running. So just to quickly show you the kind of elements of it, this is the name of the pod. These green buttons are the actual events that are being emitted by Kubernetes. So successfully assigned by the scheduler. It's pulling the image, it's being deployed, starts the container, everything is good. This is our container. And one more thing that you can do is if you click on name of anything inside of this visualization, you get a lot more information that's live refreshed about this object. So it's cool to kind of see what's happening and how the system is responding. All clear? You think? Usually I get around here like, oh wow, this is awesome. Okay, cool. So we just did this. Let's run a few more kind of commands. Thank you, Eric. Let's run kubectl logs just to show you that the kubectl command also has a few more of these kind of niceties to help you interact with Kubernetes, not just do CRUD operations. So if you're on kubectl logs and then the name of the pod, which is my app, here we see this hello Kubernetes that's actually been emitted on the std out of the cluster. So yeah, you're working on a real cluster, stuff is actually happening. Okay, let's proceed. Let's delete it because it's not very useful. So kubectl delete pod my app. So this is a standard pattern. kubectl then an action delete kind pod name my app, which means delete exactly this pod here. We see a new event, stopping container. Okay, that's good. So what we'll be doing right now is a kind of short version of our day-long kind of event where we deal with how to do zero-downtime deployments in Kubernetes. When I was talking about the deployment, it's a very useful kind of controller that maintains a certain set of replicas running, but it also does a few other things that are important. The key one is the self-healing, which means if something goes down, it will schedule new ones to appear. The scalability, which means you can actually edit a running object and say, I have 3 replicas running now, I want 50. There's a cool kind of mechanism in Kubernetes that you can actually, there's an object called horizontal pod autoscaler that you can define a few kind of conditions. If the CPU in these pods is above 50%, then scale up and scale down. So you can build this kind of breathable system. You can even use custom metrics, but that's a very kind of advanced topic. And the third thing is something called rolling updates, which we'll be doing a lot now. And what a rolling update is, basically imagine you're working on your payment service version 1.6, and you're coding, you built a new image, new functionality, version 1.7, you push it to a registry. And what a rolling update allows you is to kind of slowly shut down the old ones and bring in the new ones. Kind of, it's literally called a rolling update. So slowly introduce the new versions out there. So yeah, if you see these kind of green, yellow kind of items, that means, hey, we want you to pay attention to something in the YAML file. Again, if you hover over something, you get a description. It doesn't matter, you'll figure it all out. Let's just show you that you're running on a real cluster. So let's run kubectl get nodes. As I said, everything's an object, including the nodes, the machines that everything's running on. Here you can see, hey, I have 1 master and 2 workers. It's a real cluster. If you run kubectl cluster info, okay, here is your DNS, and it's not super important, but yeah, we just want to show you it's a real cluster that you're working with. And now comes I have to do a proper kind of setup right now. What we'll be doing right now is how do I explain this? We'll be introducing a certain problem, and then we'll see how Kubernetes allows you to kind of fix this problem very easily, even though it's a fairly kind of complicated problem. What we'll be working with is 2 different Docker images that we built simply for this exercise. So we'll be, the idea is, I don't want to show you like this standard kind of hello world example. I find that people learn much more when there's like a real goal that we need to solve. So we'll be using 2 different images. One is called a simple server and one is called a delayed server. And what they will be doing is, they're simple Go programs. They're very similar. So the simple server will just return its host name, which is basically the name of the pod it's running in. And the delayed server will do the same thing, but it will just do, before starting to actually do the work, it will do sleep for 10 seconds. And the idea behind this is just to simulate a very kind of common scenario where a process is running technically, but it's not doing anything useful. An example would be, if you're running a large Java application, then usually it takes a bit for the JVM to warm up, or maybe some migrations need to happen. The idea is, from a kind of supervisor Kubernetes perspective, the process is running, it's just not doing anything useful for us. We'll see a kind of problem that kind of occurs with the situation, and then we will try to fix it quickly. Okay, I think it'll become clear very soon. Checking, is there questions? There are no questions. Let's do this. So let's go to the work mode and look at our deployment simple.yaml. So I hope it's kind of familiar by now. Kind deployment, name simple. We already see this is the template. This is what will be actually producing the pods. It's running the simple M server. It's running on port 8888. Let's deploy it and see what happens. It's applied. So kubectl apply f deployment simple.yaml. Okay, here we see something different. So we still see our pods, but now it's actually wrapped under 2 different objects. So I've been lying to you a bit so far. I've been saying that a deployment maintains a set of replicas running. That's not technically true. A deployment manages an intermediate object called a replica set, which then manages a certain set of replicas running, in this case 1. And we'll see why it's useful very soon. But as always, you can click on it and see much more information about this object. But what's important to note is this is one of the reasons why we built MSB and why Kubernetes is very good about it, because you can visually see what's happening. So you don't have to follow along. Let me just show you real quick I'm going to just kill this pod. And if you can just see, and I want to show you what the basic purpose of a deployment is. If I do kubectl delete pod, the name of this pod, it's shutting down, but you can see immediately a new one got restarted. So there was a question, how long does it take? It's like, for any kind of normal deployment, it's extremely fast. There is no stuff in between. Okay, so we have this situation right now. We have a deployment, maintaining a replica set, maintaining one replica of this pod. If it goes down, new one will be created. We have to be able to kind of access it somehow. Let's run right now, and I'll explain why. So we have a command here, kubectl apply f service.yaml. So please run it right now, and there's a reason why I want you to run it now, and then I'll explain what it does. So if you remember, the service is this kind of networking abstraction. So it defines a set of pods to route the traffic to. So in this case, this pod, we want to do it. And how to do it is by having its selector match the labels of this pod. So I'm just going to switch back quickly to the deployment, and we see that the pod definition itself defines the label as app simple, right? And if we have a look at the service we just created, we see the selector app simple, which means all the traffic going through this pod to the service will be routed to all the pods that have this label. In this case, it's only one pod. But concretely, what this means, let me show you. So what we've done now, as soon as you create a service, magic happens in the background, and this allows you to use the name of the service as a kind of reference, a host name inside of your cluster. Which means right now we can run, so yeah, what it's doing is it's listening on port 80 and it's targeting the port 8888 because the pods itself are running things, the containers on port 8888. Let's see what it does exactly. What we can do is now is, I think it comes next. No, let's stay here. So let's run kubectl. No, let's run, I'm just going to show you curl simple, which is the name of the service. So since this whole system is running, the IDE is running inside of the cluster, this is working. But basically what's happening now is we're running a request. It's going to this IP of the service, and then it's being routed to the pod itself. And you can see that it's returning the name of the pod, the host name. You can see BJBWC. So does this make sense, what's happening right now? So one more thing that I would like to show you is, instead of us running curl, what you can do in MSB is if you click on this port, it will send an actual HTTP request. So this will be using a lot to kind of debug things. So once we click this port, is it clear like this here? We will be doing basically a curl command, and it's going to this pod exactly, and it's returning its name. So this is the basic building blocks that we'll be doing this exercise with. Is this clear? Or maybe a better question, please tell me if something's not clear, because it's gonna get more complicated quickly. Okay. Okay, this is the basic setup of our kind of problem. Let's show you a bit about a few more things that a deployment does. So we now have this scale command that's here. So let's run kubectl scale, and then the pattern deploy or deployment. Deploy is a shorthand for deployment. So kind deployment name simple, which means this deployment here. Replicas 3. Okay, this is what has what's the purpose of our deployment. So you can see how we very easily just spun up more replicas. So technically, what this means now, you can see that this service now sees 3 pods under its maintenance. So what it means is, as we are running basically curl commands, sending requests, you can see that different pods are responding. So for you, this is going to be different based on how your pod is named. But this is the idea, that you can have 1 or 50 or 1,000 or whatever services, pods behind it, but you're just always targeting the service and it's routing traffic behind it. So, okay, we can just do curl simple. And if you're running multiple of the, multiple of these, you can see different pods are responding. It's scaling up and down, and the system is working well. Will the scale be persistent even if we delete the deployment and reapply? No, that's a very good question, because you should not be doing this kind of scale operation much, but it's important that you know that you can do it, and we'll get to it later. But it's very important that everything that you do, you should actually edit your YAML file and then reapply it, and then Kubernetes will respond, and we'll do it very soon. The idea is that Kubernetes allows you to do these manual kind of operations on the cluster, on the state of the cluster, but it's a very bad idea. Obviously, you have to do it if everything's on fire and your CTO is yelling at you. But if there's a mismatch behind it, if you do certain things, patch it and forget to kind of do it actually in the YAML files, that can be dangerous, because suddenly your system goes wild and nobody knows what exactly it's running there. Let me, which component monitors the containers inside the pod once it's deployed? I guess the kubelet, the thing running on each worker machine. I want to show you something now. What we've done is, why I wanted us to deploy this service very soon is for this reason. Let's run kubectl get service. Just to show you here, kubectl get service. So the service that we actually deployed is a type of a load balancer service, which is this cool service that I've been talking about that gives you an externally available IP. The reason that I wanted us to do it is because we're literally contacting them with GKE and deploying a load balancer, which takes a minute or two. But by now you should all have this external IP filled or assigned. So let me just show you how cool it is. Like, you can copy it from here. Let's say, okay, let's copy it here. Or you can see it here on the side if you click on the name of the service. But now what we literally did is, if you go to this IP address, you can see our pod responding. And maybe take a moment to appreciate how cool this is, and like think how, like, usually when you do these things, try to think how hard it would be to do them without Kubernetes. But you just said, I want a load balancer service, I don't care, deal with it. And now we have an externally available IP that you can use. Have you all managed to replicate this? What's the algorithm using load balancing? From what I've seen, it's fairly randomish. Somebody like, who are there people that have gotten an external IP? So if you haven't, maybe just run this kubectl get service several times. Sometimes it happens that, Google, somebody takes 5 minutes, but is there anybody that got IP assigned? You will have access to it, but does anybody have the cluster assigned? Yeah. If somebody's got it, it's cool. It says, why does the external IP return the same pod ID? It's because your browser is actually keeping a persistent connection. So it's going to the same. But if we were to do, let me just open up a new terminal on my machine. No, oh no. Curl. Now you can see if you are running, the browser is just keeping a persistent HTTP, TCP connection all the time. But if you're running curl outside, you could see that different pods are responding. But it's pretty cool, no? Okay. So now that we've got this setup, I really want you then to just do one more thing, and then we can do the problem kind of. Just check the time quickly. So the final thing that I want to show you. So we went. Radhika, I'm sorry. It's really not that like important. I think it will appear. Maybe just give it a bit time. But it's just a kind of gimmick to show you. But yeah, thank you. You'll have access to, like, I'll show you, you have access to MSB, you can play around with it definitely. So, and the final thing that we need to cover is the concept of rolling updates. So if you can go to a deployment simple.yaml and let's change the version. So the idea is, okay, there's a new version of something going on, we're deploying it. So let's change this version in deployment simple.yaml from simple n server 1.0 to 2.0. And it's going to autosave. And then let's reapply it. So we change it to version 2.0 and then kubectl apply f deployment simple. So let's have a look now in the visualization what's happening, and now you see what's the purpose of our replica set. You can now see this, the old ones slowly shutting down and the new ones restarting. And this is the idea of a replica set, that it kind of maintains a history of your deployments, so of your kind of version deployments. So you don't have to follow along, but let me just show you quickly this. The idea is, imagine you deployed something and, okay, something's going wrong. You can quickly do, will we have a new replica set? I guess the question is if we do a rolling update. Yes, like you can now see there are two replica sets here. And let me just show you what's the purpose of it. If you do, imagine something went wrong, kubectl rollout, undo, deploy, simple. Suddenly you can quickly revert back to the old configuration. You don't have to follow along. I just wanted to show you. But I'm going to be rolling it back again to a new version. But the purpose of this is to both show you how a deployments controller and replica set are working when you deploy new software. But also then the idea is, as this update is happening, you can see that requests are actually going through nicely. As the new pods are being created, that endpoints controller, if you remember, is recognizing them. And we just had a smooth transition to a new version of software without any requests failing. So you can see this is a very standard pattern. Obviously, you run stuff in a deployment and you expose it through a service using the labels, and then you just access the service, and in the background, it smoothly kind of upgrades. So this has been the nice kind of version of how the system should happen. But now what we are going to be doing is going into a problem solution. I hope you understand what's been happening so far. So we'll be doing the same thing with a different image, and we'll be encountering a problem. So let's delete this deployment we have here. And let's get rid of the service because we'll be creating a new one. So right now, we'll be doing basically the same thing we did now. The question is, how are all replicas running on the same port? Because they all have, they are all individual kind of islands of execution. So they are not sharing the same machine. They are not sharing anything. Each pod has its actually own internal cluster IP and a specific network stack. So they are not in conflict at all. So if you remember, when there are several pods, they all have their own micro environments with their own network stack. But yeah, different pods are in no conflict with each other. They're not sharing a network stack at all. I hope this answers the question. But very good question, thank you. We can show it a bit later if we have time. What we'll be doing now is going into the more complicated example. So we'll be working with deployment delay.yaml. It's basically the same as before. We're just running, this used to be simple server, now it's a delayed server. So let's apply it. This time we specify 3 replicas immediately. And okay, the question is, after rollout undo, the new replica set is deleted. The answer is, okay, I'll show you now when we do it. It's not like the purpose of a replica set is to have them all kind of in a history, but they're all shut down. They're not doing anything. They're just like a configuration. But they're not activated. They're maintaining 0 replicas, and that's it. You know. Maybe we can show it right now. But yes, very good questions. I'm liking this. Thank you. So on the surface, the situation is the same as before. Let's obviously we want to contact our pods. Let's create a service. Right now, we'll be using this command called expose. I just want you to know about it. But usually you would have to write your own YAML file that's exposing this properly. But let's now just run kubectl expose deploy delayed. So what this will do is create a service for you. And what it will be doing, if you click on this, it's going to be routing traffic to these pods here. So let me just see how, like a bit of a, so what we did before, we were able to do curl simple and it went to this pod. Like, please don't to the pods of this deployment. I just want to say that like they are both called, the deployment and service is called delayed, but it doesn't matter at all what they're called. The labels are important. So just want to clear the confusion. But right now, if I were to do curl delayed, there's an issue. Can somebody maybe debug the situation and see why our request is not going through? Benno, yes, port. This was quick. Awesome. Benno, answer to all panelists. I just realized I've been getting maybe questions and answering, but if you're using the chat, please switch to all panelists and attendees. But yeah, awesome. Thank you. So the problem is last time we defined the port as 80 manually. If we don't specify it, it's just using the port of the pods themselves. So in this case, it's listening and routing traffic to port 8888. So the correct, what we should have been doing is curl delayed 8888. Okay, is this clear? Yeah, Manish, it's very good. The sleep is definitely will be an issue, but it's only for 10 seconds, so it passed. So I would like you to kind of have a look at my screen right now and not follow along. I just want to explain the problem that we're going to be encountering. So right now, everything is going great. We can send the requests and it's good. So I'm just going to show you now what's our problem. So if we scale this up, I'm going to say 6 replicas. Okay, it looks all good. They all went in the ready state, but let's see. Okay, connection refused, connection refused, connection refused. Okay, this returned well. So it was routing to, after 10 seconds, it should be okay. But you could see that basically half of our requests fell through. And the reason is the pods were in a ready state. It's from like what Kubernetes sees, what the supervisor sees is the process is running, and that's basically what it can do. All it can do unless we tell it something more. But so the system works as configured. It's just that for 10 seconds, half of our requests have been failing. And I hope that's an unacceptable situation. I've been working in some places where that could be unacceptable, but that's not important. I'm just going to return back to 3 pods right now. But is it clear what is the problem right now? So the process is running, the pod is in a ready state because the process is running. It's just that for 10 seconds, everything is failing because of the sleep time. Is this okay? Okay. So we'll be doing now the same thing as before, I think. Yeah. Let's do this rolling update that we did as before. And when we do it, then I would like you again to run these requests and you'll see an even worse situation. So we'll be working on deployment delayed and we're going to be doing a rolling update, which means we built a new image. The question is how it decides which pod needs to be deleted in case of a scale down. Oh, okay. let's do this and then I'll get, because it's a bit of a complicated answer. Let's just run this and I'll try to talk about what's happening. So we'll be editing the deployment delay to 2.0 and reapplying it, doing a rolling update. So kubectl apply f deployment delayed. And a new replica set got created, pods are shutting down, and now look, for 10 seconds, everything is down. And obviously this is a very bad situation. 10 seconds have passed, and things, after 10 seconds, things are good. Just to answer how it decides which pods get shut down and recreated, it's very important to, as I said, pods are cattle, and as far as you're concerned, it's random. So the idea behind a deployment is just creating, like all over the place, these kind of pods that have basically no identity of their own. If you want, if you need identity, if you need a certain order in which things are deployed, and it's a very important controller, you use something called a stateful set. And we have literally a whole day literally devoted just to that. But with the stateful set, it's very similar to a deployment. It's just that it's very nicely named. So it would be delayed 0, delayed 1, delayed 3, and it would scale them up and down in this way. So it's a different kind of trade-off that you're kind of doing. I would recommend, if you need to know which pods are being shut down and up, you use a stateful set, and it's a bit outside of this cluster. So the question is configurable in deployment. The answer is no. You would literally use something different. You would use kind stateful set to do it. It's a different object. What you can do in a deployment is with these two knobs, you can specify how quickly the transition should happen. So you say max unavailable 1, which means from the specified number of replicas, 1 can be down, and the max surge is how many new ones are created at a time. So the idea is that, you know, you can either have a slow transition or a very quick kind of transition. I'm just checking the time. We're getting close to the end. So I hope everybody understands the problem that has happened right now. Basically, a bunch of the requests fell through simply because from Kubernetes' standpoint, the pod is ready. It is kind of ready. The process is running. It's just that it's not doing anything useful. It's a very kind of common problem. So this is the situation that we obviously want to avoid, and the solution is actually simple. And I like this kind of concept just to show you, like I think I said it already. The worst thing that you can do is just know just a bit of kind of Kubernetes to, you know, deploy your stuff and then complain to everybody it's all over engineered and too complicated. If you don't like make an effort to learn all these abstractions, of course it's too complicated, but you get so much out of the box that for free, simply if you know how to use it properly. So what we'll be doing now, and somebody else that they want to learn about probes, and we'll be using actually this concept called a readiness probe. And I'm going to zoom in this here a bit right now. So please notice we're adding it on the container level. So we're adding something called a readiness probe, and there's a bunch of these kind of knobs that you can tweak on all of these objects. And I think it's fairly self-explanatory. So the idea is we're going to be running an HTTP GET type readiness probe, which means literally send an HTTP GET request to a path root port 8888. Initial delay seconds is 5, which means wait for 5 seconds until doing a first request. This is every 5 seconds repeated. And the success threshold means in case 1, which means as soon as you get to nice 1 to 100, that means it's ready. So this is now just kind of tweaking it a bit in a way that's saying it's not only enough that the process is running, I need this probe to actually succeed. And this is a very kind of common mechanism that's used in Kubernetes. So let's delete the deployment, and we'll just to kind of make it simpler a bit. kubectl delete deploy all, and let's turn this back to version 1.0. And we'll be just doing this same process right now. But what we'll be doing is we will be editing our deployment to add the readiness probe. So it's important for you to have a look at the structure and where to put it. So we are going to spec the template, so the pod template, the spec of the pod template, and then on the container level, we'll be adding this readiness probe. So you can add it anywhere in the container as long as it's the root key. I'm just going to be adding it below the image. So the question is, can we define a success response? So this is a very kind of trivial example. It's usually used by these kind of health Z endpoints, and it's not trivial, it's very useful. But what you can do is there's different types of probes, and one is how do you call it? I don't know. It's running an actual command, so you can literally put a bash script there that's going to be running. So you can do complicated examples in it if you need something more complicated. But usually this is used for this kind of health Z endpoints. Cool. Let's add the readiness probe. Readiness probe on the container level. So 2 spaces indentation. Type HTTP get path root port 8888. Initial delay seconds of, let's say 3. You can put whatever you want. Period seconds. Again, 3 seconds or 2 seconds. Success, which I always misspell. Threshold 1. So we just added this kind of tuning to our configuration, and let's see how things behave right now. So I'm just going to give you a second to kind of fill it, but I think you can basically copy paste it if something is stuck. Oh, if you're having trouble working with YAML, we have a deployment full.yaml here, which is basically the solution to the problem. If you know, maybe you want to do it on your own. I'm obviously doing YAML files all the time, so I'm used to it, but it takes a bit to get used to it. So let's apply this new configuration. Apply F, deployment delayed. I've changed the image to 1.0. It would be okay if you did. Let's see what's happening now. Okay, we created it, and you remember now in MSB everything like got called, which means it's ready. And if we try to make requests now, it says, hey, there are no endpoints available. So literally, it's not ready to serve traffic yet. So after 10 seconds, you see, okay, now they're in a ready state, and now we can run these requests. So let's do the same thing as before. Okay, we've applied it. We can scale it up now. kubectl scale deploy replicas 4. If you remember the last time we did it, like right now, a quarter of our requests should be failing had there not been a readiness probe here. But now everything is running smoothly until the pod is actually ready to serve traffic, right? And let's do the thing that we did before, which is a rolling update. So change the version to 2.0, or if you have 2.0 to 1.0, it doesn't matter. We just need to change the template so it triggers a rolling update. Apply it. Okay, we are already familiar with what's happening here, but the cool part is as we are making the requests, nothing is failing. And with just this small tweak, we now have this kind of smooth transition and everything is nice. And had we not known about this very kind of simple thing, we would be building our own custom weird solutions to deal with it, which we have seen a lot, and it's simply not good. I like this example because it introduces a lot of things concepts of Kubernetes and how things are working, but we're also solving a problem. And I like to show you, like, as I said, the worst that you can do is just do a little of it. Another thing that you may have noticed is, even though we scaled to 4 replicas, once we reapply this YAML, the YAML configuration rewrote it. So the new replica set has only 3 replicas. Are there any other configuration aspects regarding enforcing zero downtime that are important? Oh, yes. It's a whole day thing. You can do init containers are very important, which are containers that are running before the main containers, and their purpose is to ensure things are okay and die. There are then a few more advanced. What we cover still in our whole day workshop is blue-green deployments and canary deployments, which is basically a way to test out and route a part of the traffic to the newer version and see if everything's functioning well, and then proceed with the rollout. But these are more advanced patterns. I have a trick question for you just to see if somebody's going to answer this. I like to do this in the end. So I'm going to take a random pod. I'm going to take its name, and you don't need to do it, but just kind of pay attention. So I'm going to delete the label, kubectl labeled pod. I'm going to delete this its label app. So what do you think will happen when I do this? Can somebody tell me? It will be removed from the endpoint controller. Yes, definitely, very good. So traffic will no longer be routed to it. And yes, that's awesome. And it will be removed from the replica set, but it will not be deleted. So as soon as I do this, you can see it's now out of the replica set. It's a standalone pod, and the replica set immediately notices, hey, I'm missing a pod, and a new one got started, and now you see a probe being run. It's all good. I think that's it. Yes, we're like 5 minutes late. I'm sorry about this. I hope you had fun. Two things are, we've been on workshop.msb.com. We have a whole learn.msb.com where we have our like self-paced library that you can go through all of these things on your own. It's constantly being updated. The content is being developed by Nigel, the Kubernetes book author. So feel free to play around here. You don't even have to follow along with the lesson. You can just mess around and see how things respond. I do it all the time. If you think this is useful, and like what we now mostly work is companies that are in the middle of a kind of Kubernetes transformation or are thinking about it, then we go in with these workshops and like build up a core team of people that are then driving it through. If you think this is useful, just go to msb.com, hi at MSB, send us an email, or me personally, mislav@msb.com. Feel free to reach out at any point.